yeah, um, get started with the presentation and why, yeah, explain you why we're all here. I think you guys signed up for the 3D printing class because you're kind of curious how this thing works. And today is our first session. And what I wanted to talk about today is like just the basics of 3D printing, the overview like of how do you go from idea basically to to a printed object, and also some introduction to CAD. CAD is computer aided design. That's like 3D software. We'll talk about that later, but that's I think essential for any kind of 3D printing process if you're not just downloading a 3D model and printing it right how it comes. We have another day where we want to go a bit more into CAD, then also into different measuring and material properties from printing. The modeling itself for 3D printing is important. What to consider when you 3D print, it's different than from designing for other manufacturing techniques. We're also talking about on day 3 about different designs. I would say limitations of 3D printing, and then we'll have the 3D printer the last day also in detail, and also the software and the printing process. So if we switch back to my picture, so just to show you, we got a 3D printer here. You can all see it, yeah. So that's what we're going to be working with. I'm going to demonstrate also a little bit about what how it works. We're going to print something, and hopefully we're also going to print one of your models. But first of all, yeah, who's the guy talking here? I think, I mean, that's me. My name is Florian. So I'm from Germany. Let's say not so fresh here in Sri Lanka anymore. I arrived last year in November on a mission to open or start a maker space at Hatch. So me personally, why I'm doing this is I'm an industrial designer. I just put some pictures here about stuff that I designed. So it's like a 3D motion device, like for exhibition centers that you can see here on the top. I do like furniture design, like woodworking, but also working with traditional crafts and modern technologies. As you can see, like this chair here, the bottom part is CNC carved, or I think something I also want to look more into, and I think becomes more relevant right now as well, is the e-mobility. So that's a design for an e-bike that's a little bit older, but still I think now more interesting than ever, since with the crisis I think people want to travel more individually. But anyway, so I was saying the maker space. So what is it? It's called Maker Studio at Hatch. So this is an open workshop for anyone to come and prototype their ideas. And right now this is just a rendering, but I hope we can open doors relatively soon. Construction has been stopped, but now continuing this week. And in the Maker Studio, we're going to provide a lot of tools and machines. And this is why we're starting with a 3D printing class, because these tools and machines shouldn't just be operated from workshop staff. It should also be operated by the community. And I think that's the plan in the long run, is like that the community can use this space as if it's their own workshop, and also hopefully treats it as if it's their own property. But so in order to operate there, I think there's some basic knowledge needed, and that's what we're doing with the 3D printing class today. But there will also be more classes, because we got a lot of really cool equipment. So you can see on the right-hand side on the top, that's the 3D printer we have. We're working with right now, but hopefully we're also going to get a few others. Then we have a laser cutter, the Epilogue Fusion M2. It's a powerful laser system. You can cut anything, any shapes in 2D. So that means you put your material inside. That's usually a sheet material like plywood, plexiglass, cardboard, thicker cardboard like that. And that's something we cut it through with a laser beam, or you can even engrave also metals like aluminum, like softer metals. So it's a very cool tool. It works very fast. It's often used in architectural model making, but also for right now, these times we want to produce some face shields, for example. Then you see we have a Roland MDX40A. So that's CNC milling machine. So it's just for your info, this is not scaled, these pictures. So that's way smaller than the laser cutter. But you can build something in the size of 20 by 20 by 20 centimeter. So, and it's a milling machine. That means it has like a milling bit on the router spindle. So, and that goes, that drives like X, Y, Z directions, and you can carve from a larger block of material, such as could be plastics, wood, plywood, MDF, different type of materials. So, and very accurate, very cool thing to have. But you could also, for example, just use it as a router for PCB boards. Yeah. So, and then another thing we got here is the GraphTech. That's a vinyl cutter that you see. The vinyl cutter is for sticker material mainly, or paper or thinner cardboard. It's also, yeah, actually a nice device. I've been trying to make some paper sculptures with it. I created some stickers with it. I don't know if you've seen it on the design market. That's where I brought the machine and we created some, I don't know, like animal stickers, whatnot, just fun stuff. But you can also use it for signage or many different purposes. That's up to your creativity at the end. So, and that's yeah, also I think one of my first questions, and you can answer in the chat what's important for you during this course, but also looking into future courses. So, I mean, we're talking about CAD, of course. There's going to be a few inputs and demonstrations about different CAD software, which could be helpful. Of course, also for other projects, then how to use a 3D printer in general. I think that's something probably why most of you signed up and what you definitely will learn. Then knowledge about digital fabrication. I think that's something more broader, so we can also have a little discussion about the other tools and how to basically produce or bring some idea to reality with a different set of tools and not only 3D printing. Then design skills. I think that's something we cannot go too much into detail. That comes over time. I mean, but yeah, an experience. But that's something, of course, you get to know different tools for designing, and you get to know, like, you get to know how to, sorry, just lost it. Yeah, get to know the tools, and I would say some basic considerations more about structure or functionality. But that could also help you to build a project that you are currently working on. That would be the other question. If you have anything very concrete that you want to work on, or questions, we can also maybe connect on the side of this meeting later or in the next couple of days. So that's more or less the introduction. do you guys have any questions? Otherwise, I'm just coming back to Zoom to have a look in the chat. Like, let me know if there's anything you want to know right now. Otherwise, I would just continue. Just feel free to, yeah, just whatever you got in your mind, just to hit me up in the chat here. I might not see it right away when I'm in the middle of the presentation, but I'm always like trying to switch back and forth. So, and have a look. So then I think, yeah, back to my very beautiful presentation here in, sorry, in, so, let me switch back to Chrome. There we go. I hope everyone can see it. Yep, okay. So, digital fabrication in general. I mean, yeah, I just mentioned it. It's about machinery that is used for, I would say, rapid prototyping mainly. I think digital fabrication is rather used in trying things, exploring things, researching, making prototypes than actual production. I mean, we can also find some examples of digitally fabricated things, but in modern products or even vehicles like aircrafts or something, the parts of the Airbuses or Boeings that are 3D printed right now, or even Tesla is 3D printing for their space crafts. So I think that's all legitimate, but still, when you look at the products you have at home or everything, that's often, I would say, mass produced with injection molding or something. But I think the more we are using these tools of digital fabrication, I think the more also our product world will change in the way we produce. So this is why I find it super interesting. And but I would say it's not new, the whole thing. So the first 3D printer was actually built in the 80s. How come that we are now working with 3D printers so much is about actually the wrap. That's the picture you see on the right. That was the first, I would say, affordable 3D printer for hobbyists or smaller workshops. Until then, 3D printing was very expensive and only for larger companies or R&D centers or something. So, but with the wrap up, I think that was the first project. It's open source software. Everyone could just rebuild it. It's open source hardware design. And I think that's an approach I very much like. And I hope also that's something we can discuss in the future together, how to create more open hardware tools or even open hardware products at the end of the day, because what you see is like you can easily fix and replace every part. This thing will never break entirely that you would have to throw it in the trash. You can always just print a spare part or find a new component, upgrade it. I think that's a very cool design and a very cool idea of digital fabrication in the future. To give you an overview about the different ways of working with material in digital fabrication, is like there's additive, subtractive, and forming, basically changing the shape. So very straightforward. Additive is like you add material piece by piece, like with 3D printing, that goes all the way to even layer papers on top of each other. There are machines that can do that. Subtractive is like you take a block of material and you cut things away or off. So that can happen with a milling machine, with a lathe, with punching, with laser cutting. And then there's shaping or forming. So there's like, you take a sheet material, for example, and you can bend it around a certain tool and for a different angle with a specific radius. So that's also possible. But I think more importantly, we're talking about 3D printing. Here again, RepRap product. I'm a big fan of this one. We had one back in the days in university. I remember was great fun, even though it was not, I would say, the most sophisticated technology or precise. It was rather rough, but that's how all good things start at some point. And most importantly, you can do something with it. You can achieve something. And this is like, you got an idea, you build it as a 3D model, like in the computer, like, so, and then you need to make it, I would say, ready for the 3D printer. And how that happens, I think, is, I'm giving you the overview here. A lot of these steps are now, I would say, automated. So, for example, when you create an STL format, a file, that's already pretty advanced. So STL is standard tessellation layering format. That just means like from a 3D object, you just break it down into small triangles. So, and to create a shape so that, and it's a closed shape, and that is the file format you use for a printer software. So it's something like a printer driver, but it's more visual. So you load your 3D model then in the printer software. And in the printer software, you can adjust some of the settings. You would fix the STL format if there are any damages. Happens quite often that the model is not perfect, but latest in, at least there, you can see it, you can fix it, and that software is actually called a slicer because it just cuts it down into layers. These layers are then creating basically the, your model or your object. At the end, you can see it in that picture, how this vase, for example, is just consisting of many, many layers that are printed on top of each other. And the machine does that because it knows the coordinates, and that's what I refer here to as the G code. So the G code is really the hardware code telling your machine where to drive and where to deposit the material. We'll have a look also in how the 3D printer process actually works, or the machine works, on the next slides. But what you need to do is like set up your device. That means like clean it. There's a build plate on the bottom. It needs to be heated up. And then you're actually ready to print. You send the file, the thing starts. Hopefully everything works 100% fine, and your model is finished at the end, because also sometimes with 3D printing, you can, your model might have some errors or flaws and stops halfway. Can be very frustrating, but this is also why we do the course here, to try and avoid as many mistakes as possible. Then once you've printed, you need to remove it. So of course you take it out, and that means there is also sometimes support material or even a raft where your model is sitting on. So that's done either for precision, or if you have overhangs, meaning your printer cannot just print in the air. So there needs to be some support material. This stuff you need to remove. And then finally, depending if you want to refine it or not, put a nicer surface, varnish it, I don't know, like make it smoother or whatnot. That's the post-processing. There are also different ways, how you can take it from there. That is the standard process for actually most of the 3D printers. You can categorize 3D printers in different types. I put this slide here because I've been asked many times also about the other printers. But mainly what is used right now is FDM, fused deposition modeling. So that means you have a polymer filament that goes in the machine, and that is deposited by through a nozzle. It's been heated, melted, and then just put on a build plate, and layer by layer, your model is printed. There's other like stereolithography, SL or SLA. So that's photosensitive liquid resin. That means you have actually liquid, and there is a laser or UV beam that hardens just certain parts, and then layer by layer. You can also build it on top of each other, or you can do the same with powder. That's used when you want to print something from metal or ceramic or stronger stuff. And then there is, like I mentioned, for example, paper that you would layer, that you would cut and layer. It's also possible, but not often used. Actually, right now, I also don't know any use of the machine. So, but I think mainly we're talking about fused deposition modeling, because that's the most affordable and the easiest, and that's also the machine we have. So if I just switch back, I don't know, do we have any any questions so far? Let me just wait, where are we? Here. Guys, you're all still with me? Yeah, I mean, if we need to stop, you can tell me to stop. But yeah, what I wanted to show you just quickly is the cartridge of our 3D printer. I think that, here in the camera is, number one, what you need to know, where it starts. So what we have here is a filament. I can try and pull it out, but it's just this plastic PLA actually, so it's a biopolymer, so it's it's not bad for the environment, not super ideal, but I think it's a great great thing to have. Or great material to work with. So it melts at somewhere around 120 degrees, gets really more liquid when it's heated up to 200 degrees. And I just received a question, how safe is the FDM process when inhaled? Actually, it's quite safe. FDM is heating the material only, so it's not burning it, so you don't create actually a lot of gas. But still, I would advise you to do it in a ventilated room. So I'm also using it here at home in my home office. I've been printing stuff, and I just open the door or the window sometimes. It doesn't really get smelly, and I think with PLA it's still super okay. So that's actually fine. So that was the filament. So this one here was something I tried. That's another color. So in blue, that's also PLA. That's a face mask. So you can actually use it like this and put a cloth inside. So and it closes very well here, but you can still heat it up and then bend it into shape so that it fits your face better. So this is also why PLA is actually nice material. I've printed many more things just in the recent weeks, like that are a splitter for, it's called vent splitter. That's like for respiratory systems to connect a machine to more patients than one, for example. Yeah, but anyways, the material itself, yeah, is available here. I think one thing we hacked, because you've seen this nice cartridge, and it was proprietary material, so you could only use the material from the manufacturer, but I had a chat with them. They gave me some nice piece of software, and now we're able to use whatever material we want to. So this is a third-party material. Quite cool. Quite happy about it that this works. So we can just print away. But back to the material. Back to the printing process. So what you can see, or how it works, is there's this nozzle, and I told you, yeah, it's getting heated. It's being pressed through the nozzle on the build plate, and then layer by layer, the model is built up. So, and there is, yeah, depending on the machine, there are different characteristics. So put it here. So yeah, I don't know why it's so accurate, but 0.1 millimeter layer thickness to 0.3, depending on the material, depending on the size of your nozzle, what fits through. There are different sizes of 3D printers. So they're bigger ones. 600 by 500 by 600 is one of the biggest available 3D printers. For FDM, I would say for the hobbyist market. Of course, there is no limitation. We've seen houses being printed even in 3D, but I think that's another thing where we don't want to go now with this 3D printing class. But also because it would take forever. So this mask that I was printing took about 15 minutes to print. So, and you can imagine, so this thing you've seen, but if you want to fill the entire space, and that would be available, there would be available like 20 by 20 by 20 centimeter inside the 3D printer. We have how long it would take. I think the machine would have to print a couple of days until it's finished. So, yeah, and I think that's, yeah, the challenge. I mean, you can just start the machine, you can let it print overnight, it's fine. But whenever it gets stuck, yeah, you need to see if you can restart the process or if you have to start again. So I usually tend to split it up into smaller components. But what you usually have is like two materials. Also, that's different by printers, but yeah, what you need is a support material. As I said, you can see it here. They're like, the white is the actual model you have, and the black material is the support material. Yeah, right now with our printer, it's blue and blue because it only has one nozzle. But why you're doing this is, yeah, just think of a printer just printing in the air. It would just fall out, and you can't, the material and fall on the ground. So that would not be precise at all. So this is why you need support material. So yeah, the advantages are you don't have any toxic material that you're using. So it can be used in an office. It's yeah, very simple to post-process, I think, to finish it. And it's not expensive at all. So you can find a proper 3D printer starting from $600–700 already. Not gonna advertise what I'm doing, which ones, but yeah, we can chat about it. Of course, some you have some accuracy issues. Yeah, when you make any moving parts, an axis or yeah, bearings or something, you always have, I would say, a little bit of yeah, a few millimeters that you have to adjust, like a few tenth of a millimeter, I would say. So never like something super strong. And also these things tend to break much easier because yeah, they're kind of layered together. So that means they're not so strong in all directions. Anyways, and just quickly, because many people ask me, here's the process, how it's done with stereolithography, with the liquid polymer and the laser. You can just see the schematics of the design step by step. That's a very popular stereolithography printer here. Yeah, but you will find it when you look for it, but it's way more accurate because you're using light rays to harden the material. So, and I would say, yeah, it also goes a little bit, you can print a little bit faster. But also it has its disadvantages. I think resin is not such a nice material. Most of the resin you have, like PLA is, and it's sticky. If you mess up with the material, you have it everywhere in your workshop or in your office, depending on where you're using it. So yeah, I think, and it's more expensive, the raw material. But yeah, we mainly want to focus on printing with filament. So that's an example that I think is very intriguing. So that's, for example, for prosthesis, it's used very often because you have an individual size or fitting. And sometimes yeah, if you don't have anything else available, that's a better solution than nothing. Sometimes, and also from that, I think it's starting a process. It doesn't stop there. It looks now very rough, but then you can always iterate and upgrade. And I think that's the beauty of working with 3D printers, working with a community to develop these prototypes further and further until, yeah, they're really nice. For everyone that's SLS, just put this picture here to show you how how you can use SLS to print basically in the air. So you can create more complex parts, and you can use different materials because there the material you don't use actually for the process supports the material you need or where it hardens. So after you take it out from the powder bed or from the resin, yeah, the material you didn't use will just come off, and that's where you have then the remaining part. So in the third 3D printing process, just I found it funny in general. I mean, this guy is just printing chairs with a robot. So that's a robot arm with an extruder, but that's also 3D printing, just in a different size. So, and that's something, yeah. Let me go back, or yeah, let's leave this here. What I wanted to ask you guys is, I think that's one of the goals that everybody has used a CAD software. And yeah, what I thought would be cool is just yeah, create a name tag for your key or something, or for a friend as a gift. And the coolest name tag, we'll just print it. So I think that's achievable in the few hours we will have with each other. I mean, now you know the background of yeah, of how that works. And I think we're gonna go in the second part today into CAD design. So I'll just introduce you to that one. And I just see the questions here, which is the best 3D printer in budgets? I mean, I would say check Creality, like reality, but with a C. I think they're the most affordable. they're yeah, quite fun to work with. Most important with a 3D printer, there are some factors I can show you in another session, the mechanical details, so that you have a strong gantry, that you have, I would say it's preferable to have a heated bed that you're printed on. It makes it a bit easier. Yeah, and there are some softwares like where I say, okay, that one is easier to deal with than another. So, but I think Creality is good value for money, for example. And so, yeah, do we have any more questions? Mm, yeah. Oh, Zayanti. So, yeah, a respirator ventilator using 3D printer. Haha. I I did help a team to print some parts for a ventilator. So that has happened already. It's possible, but of course there are limitations. You only have one material. You need to put it together from several materials. So um, this material can only be used for casing or some structural parts, but of course, you also need a lot of other parts. And that all comes together in one big product. So the issue is certification at the end of the day. Like you need to get an approval. So, and one is the type of design that you're using. So we've seen a lot of designs working with the Ambu bag. That's a very quick fix. It's probably good helping people in emergency situations. But the Ambu bag design um, doesn't help people who really need respiratory support. So that's when you need intubation and everything. So that's a real ventilator somehow anyway. So it's the whole medical field is quite complex. And then the other thing about medical technologies is material processes. It all has to be certified. And this material is not certified or approved by FDA or any kind of other organization. So it's quite a headache. Yeah. But of course it's possible. And I think the international community, I can share you a Facebook link um, where you can join. It's like COVID-19 design. There are very, very good discussions in that group. And yeah, it's, I would say, it's a good idea to look there for designs, for feedback, for inspirations and ideas. So yeah, I will share the link here later if I can find it. Da, da, da. No, well, I don't have it at hand right away. But anyways, okay. Then let's continue with another, just I would say with the CAD introduction. Let me just share the presentation. So yeah, computer aided design. I think that's where we want to get started, because that's what you need in order to make a 3D model that can be printed. So you would always start from a 2D drawing and make it 3D. I think in that case, yeah, I'm using the base here again, you can see the profile, and this is revolved around an axis. So, and that's how you simply create, well, yeah, in the most simple way, create a 3D shape that can be 3D printed later on. That's, yeah, where CAD helps you to go from ideas, from 2D, from sketches into a 3D. And then there's different type of 3D softwares, of course. You can compare it to different languages almost. I mean, what's very much related is solids and NURBS, but mesh is a little bit different. But anyways, you'll deal with most of it anyways, like when you 3D print. So I prefer to use NURBS software. NURBS is basically a surface definition. So you create curves, you create a geometry, and then you develop it into a surface. That's how basically NURBS are working. So surface means it's yeah, zero thickness, and that's the difference basically to solids. Solids, you always start, it's a more mechanical approach. You start with a 2D, you extrude it, and then you have a solid body. So there is a thickness always to the material. That's solids are rather used in industry. NURBS are often used more in design to create surfaces or yeah, whatever things it is. It's more about sketching. I will tell you later more about it, why or what my preferences are or how I work. And then there is mesh. Mesh design, that's yeah, 3ds Max, for example. That's the most famous, or Blender 3D software. That's where you use meshes. Meshes are made for animation because they're not data heavy and yeah, intense for CPU use when rendering. So all games, animations are based on mesh that are flat planes, basically, triangles or squares that are connected and create a surface like that. They're easier to render and to process. So, and yeah, everything has its use or advantages, but yeah, of course, for 3D printing, we're looking more into NURBS and solids, but funny enough, once we go to the software, the printing software, and I said this earlier, we're using an STL file. That's when we turn into mesh. So, and I'm getting funny scribbles on my screen. I don't know if that was me or not, but just a quick process. CNC starts actually on a very simple level. Just wanted to show you how you create curves in a 2D. This is like a 3D view then, and then you can basically just sweep a surface over this curves. It's so free-form, but you can then triangulate it, create it into a flat surface. This is a mesh, and then you can flatten it out, and that's something you can print with your just printer at home. So this is the most simple process of digital fabrication: is make a 3D model and try to flatten it, and then you can print it and you can put it together. So, but yeah, that's something I would say is super simple to do. But also the question is, what are you guys want to do at the end? At Maker Studio in general. I mean, we're not talking about the 3D printing only, but this should be an inspiration for you guys to start thinking about making things or building things. And what I have one more slide here, and then we go into Rhino and Fusion 360. So this is about the actual lesson then in CAD software. So I just wanted to know, yeah, if you have any questions so far, if there's something you do, and I see some more question here. The rocket engine that was entirely 3D printed. Yes. 3D printing metals is, I think, was it the one used Skyroller? I don't know where it was used. I would need to see the part, but generally metal printing works in a way that you use the SLA. So that means you put a layer of metal powder, you come with a laser and you melt it just where you need it to be melted. You put another layer of metal powder and then you go around and laser it and harden it. That's how it usually goes. There are other ways of 3D printing. One is developed in Munich from the Fab Lab. I've seen a presentation. I can also share this one. They want to build a 3D metal printer, yeah, low cost, I would say. And I mean, they're developing it right now. So that works by mixing metal with plastic. And then later on, you would melt the plastic out of the metal and then the metal shrinks. So this is like a bit tricky, but I'm very curious to see what comes out there. But yes, it's possible. But the printers we are using here, and the printers that are affordable, they're using the good old plastic. So yeah, any more questions? Otherwise, I would say let's go and have a look quickly into Rhino 3D and Fusion 360. Those are both CAD softwares that I wanted to show you because that are the ones, or I'm using more Rhinoceros, but Fusion 360 is also powerful software. So both of them I would recommend. There's another one called SolidWorks people might have heard of, and where a lot of people say that's industry standard. SolidWorks is a bit more advanced in some features, but I would say it's over the top. It's something you would need as an top tier engineer, but like as a hobbyist for doing things on your own at home, the other softwares are easier to use and also to access. So there are free versions for Rhino of 90 days that you can install. So that's something I would recommend you to do. Or Fusion 360, there are free education licenses for even 3 years. So and I would say that's the advantage right now and why I would use these two softwares. But yeah, has any one of you guys used CAD software before? Anything? Just put it here in the comments. I can maybe compare to others. So let me show you what Rhino looks like. That's number one. That's the NURBS modeler. So just open a project here. So that's what I did. Actually, that's a 3D. As you can see, I'm just navigating here with a mouse, so I can view it from different angles. That's where I placed the filament spool for the 3D printer on top, because I was taking the manufacturer's cartridge out. Wait, resume sharing. I think we have an issue. Share. Okay. Is it? I hope you're seeing it. What I'm sharing. Yeah. So this is Rhino 3D. Yeah, so that was for the spool because I replaced the manufacturer's cartridge with just a spool that I bought here from Peta Market. And I needed something where you can sit on and you can be easily yeah, rolled out. So that's basically where the spool sits. I don't know if I have, yeah. So the red part, that's actually the spool, how it sits on top, and then the material can be unrolled from there very easily. So that's what you get when you open Rhino, or how it looks like. So when you start a new file, that's how it actually looks like. Um, you have the 4 windows in the middle. And that's, I would say, for how a lot of CAD softwares work, because like we said earlier, you're going from 2D into 3D. So that means you have a top view, you have a front view, you have a right view or a side view, and you have the perspective. So that's how you navigate or find orientation in 3D space. So that means if I'm drawing a circle here, so from the front view and the right view, I don't see anything. I just see a black line. But yeah, from the top, I see how it's round. From the perspective, yeah, I can navigate around with a mouse, and I can see the circle in 3D. And then what I would do next is extruding it. And that's where I need the side view, because from the top view, I can't really see what I'm doing. But from the side view, front or right, I can adjust the height. I can say, can type it either, say 10 millimeter, 20, or I can select here on the grid. So, and then I can see in the perspective, I created a 3D, and that's really, and here I can change the view, how it goes in a very easy way. And that's why I actually like using Rhino, because it's very intuitive and it's very quick to create something. But let me give you some orientation. So like any software, yeah, you have a lot of icons, a lot of buttons to choose from. But so the main focus are, of course, the 4 windows here. You can also focus on one windows by just double clicking. That should work for the Windows version as well. I'm here on Mac OS X, as you can see probably on the 3 buttons here. Yeah, same with the top. So that's how you can see it. And you have more options. I did that just now, shaded, wireframe, ghost ray, how you view it. You have many, many more options, sometimes very helpful for technical drawings. You have isometric perspectives, northeast, northwest, southeast, southwest. Yeah, very practical, but that's what you see. To create something that's on your left side. So that's the panel with all your, with your toolbox basically. So the easiest is you start with a polyline. And actually, I'm always using polylines. I never use points or anything. Polyline means you define a coordinate in space, and I usually start with 0, 0, 0. That's the origin point. And that's where you see the red and the green lines coming together in all windows. So that's like X, Y, and Z. And then 0, comma 0, comma 0 means you're starting at the origin point with 0 level. And then you can create another point if you want this one, for example. It's asking you next point of polyline, you say 10 millimeter. Now it shows you, you can choose which direction it should go. If you hit shift, then it goes, you can choose 90-degree angle, or you can freely choose here. You can always modify it later. But so this is how you would have created your first line. When you select it, yeah, that's then it's highlighted in yellow. And you find many, many, many more tools here. You can create curves with control points. You can create circles, rectangles. Like then You can round corners. You have a lot of tools to modify. So you already see you're going more into surfaces here that you're creating. Then you can, yeah, rotate. You can modify. So I think there's a lot of tools here that are very helpful. Also analyzing and yeah, going through that is, I would say, a whole class of, I don't know, half a year probably, if you want to manage everything. But there are great tutorials online that I can also share with you, resources, handbooks of this software. Um, very cool, but it's not needed right now to just get started and to get an idea. Then on the bottom here, you've seen I've selected already a few things. That's the snap, object snap. That means it helps you to find certain points. You can see now when I want to create a new line where that I come close to the end of a line, and then it says, yeah, if I want to start drawing from there, from the end of the point, or on ortho, like orthogonal, midpoint, intersection, quadrant. So you can see it here, and you have a lot of options. Play around with it, very helpful, very cool. And what you can don't get confused to is like projection. That means like you're always working on zero plane, zero level from the view. So that means when you're on top, looking from top, you're always working on X, Y level. From front, it's like the X and Z, and from the right, it's the Y and the Z level. So always on the zero lane layer. So yeah. Plane, excuse me. So that's just to help you to find orientation in 3D space. So you can see it's complex, yeah, but that's how it is. But you, I think once you got familiar with it, it becomes easier and easier and more easier to understand. Then on the right-hand side, that's something you probably know from Photoshop or other softwares. That's your layer manager. So you can choose objects, put them on different layers. It helps you super much because once your drawings are getting more and more complicated or complex, that's where you want to put, for example, the wheel on a layer where it says wheels, and you can assign different colors, line types, appearance, and you can also create like object properties. So if you want to render it or later on, underneath here on this right here. So in this window, so that helps you to adjust. So the right side is for this kind of managing your drawing, adjusting things. Left side is really for creating a drawing. So that's, I would say, that the quick overview of Rhino. Do I have any funny things that I can show here? Oh yeah, there was another design approach. But yeah, you can see it right now. I didn't name the layer, but the different colors already, they come from using different layers. Yeah, so this is it from Rhino side. Let me just go back, see if you have any questions in the chat. So is everybody still with me? Ha. So licensing restriction on owning a 3D printer? I don't think so. Actually, that's a good question because I've seen people printing firearms with a 3D printer. Of course, it's limited use only, but yeah. And right now, not that I know of that there is any kind of restriction. So you guys have been talking a lot. Yeah. Okay. Well, back to CAD. Yeah, you've seen what I've done in Rhino, and yeah, I think one of the most important tools that you, or I would recommend to use when you're designing in 3D is a caliper. I don't know if you've ever used a thing like that. um, for me, it's I always have one on my work table when I'm designing something in 3D, especially with a 3D printer, because I really want to know how thick is something, or is that strong enough? Is that wide enough to put a strap through here? And these kind of things, and then and that's what really helping me when I start designing. It's like maybe we should give it a millimeter extra here or there. Millimeter matters at the end. And with this, you can even measure tenth of millimeters. I don't know. Maybe I should put a link or a video somewhere that explains how to use it nicely, perfectly. But it's a tool I would recommend because, yeah, that's how you start. You make a sketch on paper, even for that one, and then you would say, maybe we should give it a dimension of this frame. Should be like 90 millimeter here. The length in total 120. So where does it come from? Yeah, you make a paper sketch or something. So, and this is like your reference for CAD measuring. I think that's super important because, yeah, without the connection to reality, it's really not, yeah, I would say, or it doesn't help to create something if it's not in the right size. You need to print it over and over again. So just start with this thing directly with a caliper or just a standard ruler, a small one. Also does the job in the beginning. You don't need to go super pro right away with your first design. But anyways, the other software I'm about to show you is Fusion 360. So I hope, yeah, I think you can all see it. So that's how it looks like. Yeah, if you create a new design, here, slightly different. You always have a 3D view. You can also, yeah, move around. It's an isometric view. You see it because it doesn't have a perspective. The angles are the same, but number one is how to navigate. You see this box here. I just touched it, and you can see how you can find yeah, your way. Yeah. So you can basically whatever you do, you just you don't need the 4 windows. You can try and do everything in one. I actually like the 4-window approach, but that's I think the main difference with a solid modeler. So these people coming more from industries, they're more using like tools like lathe, milling machine, and stuff. So and this is why they already think or plan designs in yeah, already considering the manufacturing later, and that's when you think of, okay, how does it look from that side, from the top, from the bottom? Is it possible? How often do I need to change it in the machine to actually cut this one off or carve this one out? So, but yeah, what you see here in in Fusion 360 is you have different workspaces on top. So that's the button number one. You have design, that's what we usually use. Then you have generative design. So that's more, I would say, advanced. You work with parameters and not with, so the computer would find a way of designing it, or artificial intelligence instead of you are giving every parameter of the design yourself, which is great constraints. You have render workspace, you have animation, simulation, even you can test with different material properties, the strength, manufacturing that goes into CAM software, meaning computer-aided manufacturing. And that's something, yeah, very advanced already. And I think, so this software is super powerful, and yeah, therefore you can compare it with SolidWorks, and SolidWorks is not that different from the way of working with a software like Fusion 360. So it's, I would say Fusion 360 is a good entrance into really design for manufacturing. So anyways, but also there you start with drawing. And yeah, from design, yeah, you need to load it, design, but wait, I don't see all my buttons. But yeah, what you ideally want to do is create a new sketch. That's how it would work. So get into the top view automatically, and then when you click on that small box on the top here, your tools would appear. So you can create here, for example, let's say a 2-point rectangle, and you can already see the difference from Rhino and Fusion 360. Here it asks you right away the size. So right now, the highlighted one, I say the box should be 150 millimeter high, hitting tap, and 300 width. So I switch to the other. So here's my box. So once this sketch is finished, I can go back to my 3D. You can see how it's flat. And that's where I can go into solid. So we're talking about solid modeler. And I extrude it. So now I was just pulling it up randomly, 75, but I can also, yeah, say just 50. And that is the thing about SolidWorks. Yeah, you can, SolidWorks or Fusion 360, you can adjust different things right away, like while you're creating it. It has more features than Rhino. So like what you were seeing here, I was saying now it's 100, but I want an angle so it is slimmer on the top, and then it comes like this. Okay. So, and then it looks quite funny. But yeah, so you have more features. So also if you want to create tools or wall thicknesses of a material, those are features here that are already built in. And then make it a little bit more comfortable to use. But I would say it's, yeah, you see how with one click I've created like this cutout. Just like, okay, the shell is 2 millimeters thick, and there we go. So that makes it, I would say, more manufacturing friendly. I would say less creative. So they, yeah, like everything, it has pros and cons. But at the end of the day, it's like your choice, how you want to work, what you feel more comfortable with. And that is, I would say, also the end of the session right now. This is really just to give you an intro how do CAD softwares look like, and what you think you feel more comfortable with, because we can go both ways. So we can create a little poll. Do you want to learn Rhino, which is, I would say, a more faster approach, or more quicker to sketch and to understand in a way, or already going a little bit more advanced, but also still really not difficult to learn. I'm still learning also myself, Fusion 360, but happy to give you an intro there and to go with this one for the next session. Because our next session would be on Thursday, and that's where I can introduce, um, yeah, some of the more advanced functions of each software, and we would go into like you designing your name tag along the way already. What do you guys think? Let me know. I think, yeah, if we can create a poll, and yeah, now it's already 10:15, so I think, yeah, for today, that's already the input. I would just ask you to digest everything. I will share the presentation. I will share the links and to the software, and maybe also to some Facebook pages if you're interested in medical design or design for respirators, ventilators. And then I would say we see each other on Thursday, or rather, yeah, you see me. I haven't seen much of you on your profile pictures, but well, um, anyways, I hope it was helpful. If you have any feedback, how I can improve, if you have more questions, I think next week, yeah, on Thursday, we'll see this, our friend Sindo 3D Vox in action. We'll take care of that. I missed the chance today uh, to get it started because it took a bit longer than I thought. But anyways, thanks for you. Yeah, thanks guys for joining. Thanks for being part of this, and I hope we can really continue with the sessions. And yeah, I would recommend you install the software, familiarize yourself with it if you have time. If not, yeah, we're gonna start from scratch on Thursday. And yeah, that's it for today. Alrighty, then I say bye-bye and gotta leave you here. Bye.